Section 2 of this chapter is all about simplifying radical expressions. Simplifying a radical means that there are no perfect square factors inside the radical. For example, we know that a radical is the same thing as a square root or a cube root, but in this chapter we're mostly going to be using square roots. If I have the square root of 4, we can simplify that to 2. Because 4 is a perfect square, and we know that the square root of it is 2. But what if I had the square root of 12? 12 is not a perfect square, but, let's erase that. But 12 is the same as 4 times 3. So technically there is a perfect square left inside the radical that we need to simplify. So we're going to talk about how to do that a little bit later. Another definition of simplifying a radical is that there are no fractions left inside of a radical. So a simplified radical could not look like the square root of 3/4. We would have to do some things to simplify that further. That would not be a correct answer. Also, no radicals appear in the denominator of a fraction. We are allowed to have radicals in the numerator, but not in the denominator. So if we had something like 2 divided by the square root of 3, that would not be a simplified radical expression. However, the square root of 3 over 2 would be okay. Notice that the square root is in the numerator and not in the denominator, so that is fully simplified. So the first property that we're going to go over is called the product property of radicals. And what the product property is if we have two terms that are being multiplied inside the radical, the square root of a times b, we're allowed to break that up as the square root of a times the square root of b. So let's use that property to help us simplify the example. So we have the square root of 4x, and we're going to break that up as the square root of 4 times the square root of x. We know that the square root of 4 equals 2, and we can't take the square root of x, so we're just going to leave him inside the radical. So 2 square root x would be the simplified version of that expression. Let's take a look on how we can use that product property to help us simplify numbers that are inside the radical. So if I have the square root of 32, I want to think to myself, what are two numbers that multiply to 32? So I'm going to say, well, I know that 32 is the same as 16 times 2. Now we can use that product property to say that that is the same thing as the square root of 16 times the square root of 2. The square root of 16 is 4. We can't take the square root of 2, so we're just going to leave him inside the radical. And he is completely simplified. If you picked two different numbers besides 16 and 2, that's okay because it will still equal the same answer in the end. So let's say instead of 16 and 2, you picked 8 times 4. And then using the product property, we can break that up as the square root of 8 times the square root of 4. And we know that the square root of 4 is 2. So we have the square root of 8 times the square root of 4. So notice that we're not to the same answer for root 2. That's because the square root of 8 can be further broken up as 4 times 2. And then we still have this times 2 on the outside. So that would be the square root of 4 times the square root of 2 times 2 The square root of 4 is 2. We can't simplify the square root of 2, so we leave him. So we get, again, the final answer, 4 root 2, because 2 times 2 is 4, and then that root 2 stays in the radical. Let's try doing the same method with the square root of 24. So I know the square root of 24, we can break that up as 6 times 4. So that would be the square root of 6 times the square root of 4. We know the square root of 4 is 2, but we can't take the square root of 6. So it looks like our final answer is 2 root 6. Now you might say to yourself, well, 6 is the same as 3 times 2, but you can't take the square root of 3, and you can't take the square root of 2 easily, so we just leave our final answer as 2 square root 6. There are no perfect squares left inside the radical, so 2 root 6 is the most simplified form of the square root of 24. Now we have a variable inside this square root, but we're going to break it up the same as the square root of 25 times the square root of x squared. And we know that square root of 25 is 5. And we also know that square roots and squareds undo each other. So the square root of x squared is just x. So our final answer is 5x. Now this problem is a little bit more difficult because we have the square root of 9x cubed. It's not the square root of x squared anymore. So we're going to start by breaking it up the same way as the square root of 9 times the square root of x cubed. And we know the square root of 9 is 3, but the square root and the cubed don't cancel each other out because they're different. However, we can break up x cubed as x squared times x to the first. As you'll remember from a couple chapters ago, x squared times x to the first equals x to the third, so we can break it up like that. So then we have 3 times the square root of x squared times the square root of x, and the square root of x squared is x, so 3x square root x is our final answer. Now we're going to try some more difficult problems. So for 14, we're going to break it up as the square root of 8 times the square root of x to the fifth. The square root of 8 we need to break up further so we can simplify it. So we know that the square root of 8 can be broken up as the square root of 4 times 2, and x to the fifth is the same as x squared times x squared times x to the first. 2 plus 2 plus 1 is 5. So now we can further break this up as the square root of 4 times the square root of 2 times the square root of x squared times the square root of x squared times the square root of x. So 2 times root 2 times x times the square root of x. So notice that for this problem, we have some numbers and variables that ended up outside the radical, and we have some that are still in the radical. So the variables that are on the outside of the radical are going to stay there. So we have 2, and x times x is x squared. And then we have our square root symbol, and we're just going to put a 2x inside. And that is the final answer. 15 is the square root of x to the 7th, y to the 4th, z cubed. We're going to do the same thing that we were doing last problem with the variables and trying to break this up with as many x squares or y squareds or z squareds as possible. So we know that first we can break this up as the square root of x to the 7th times the square root of y to the 4th times the square root of z cubed. So let's break up the x to the 7th first. So that's going to be x squared times x squared times x squared times x. 2 plus 2 plus 2 plus 1 is 7. Then we have, for y to the 4th, y squared times y squared. And for z cubed, we can do z squared times z to the 1st. Okay, now further breaking it up, we have the square root of x squared times the square root of x squared times the square root of x squared times the square root of x, and then the square root of y squared times the square root of y squared, the square root of z squared, and the square root of z. I was able to fit it all in there. Okay, so the square root of x squared is x times x times x. This does not get it to leave the square root, so we'll just leave them in there. And then y times y times z. So I was doing that on the z's. Times the square root of z. So it looks like we have 3 x's outside the radicals. That will be x cubed. We have 2 y's, y squared, 1 z, and then still inside the radical is an x and a z. So that is our final answer for 15. We're going to use the same method for problem 16. So first, let's break it up as the square root of a to the 5th times the square root of b times the square root of c squared. A to the 5th is a squared times a squared times a. We can't do anything with the b, so we'll just leave him. And we already know what the square root of c squared is. It's just a c. So if we break this up even more, we have the square root of a squared times the square root of a squared times a times the square root of b. Oops, square root of a. There we go. Times the square root of b times c. So a times square root of a times square root of b times c. A times a is a squared. The c is outside the radical, and we have 1a and 1b left inside. Pause the video, try these problems on your own, replay the video, and check your answer. Here are the solutions to the 4 practice problems. Check your work, check your answers. Go back and try them again if you did not get the answers correct.